transfer through a composite wall. Now, composite wall means there will be more than one layer having different types of materials. Here in this figure, this one is layer 1, whose thermal conductivity is K1. This one is layer 2, thermal conductivity K2, and this one third layer, whose thermal conductivity is K3. Now, the outer temperature of this first layer is T1, junction temperature T2, followed by T3, and inner temperature is T4, where T1 is greater than T4. So it will flow from this direction to this direction. So we can write Q, the direction of Q. Now, thermal resistance for this one is denoted by R thermal 1. For second layer it is R thermal 2, and third layer it is R thermal 3. Now, according to Fourier's law of heat conduction, we can write Q is equal to minus K dt by dx, where T1 is greater than T2. So dt is equal to T2 minus T1, that is, this one is negative. So we can write this equation Q is equal to minus K T1 minus T2, as this one is negative, divided by L. L is dx. Here this L is equal to dx. So finally we got the equation Q is equal to T1 minus T2 divided by L by K. Now this L by K, this one is called thermal resistance. So for this figure, R thermal 1, that is thermal resistance 1, this can be written as L1 divided by K1 K. L by K. For second one, this is K1A. Second one, R thermal 2, that will be this thickness L2 by K2A, and R thermal resistance 3, this is equal to L3 by K3. Now for these three layers, this surface area, this is equal. Now finally, we can write equivalent thermal resistance equal to R thermal resistance 1 plus R thermal resistance 2 plus R thermal resistance 3, as they are in series. Now we can replace R thermal resistance 1, 2 and 3 by L1 by K1A, L2 by K2A, and L3 by K2A. So finally we will get this equation L1 by K1A plus L2 by K2A plus L3 by. So finally we can write rate of heat transfer through this wall, that will be temperature difference between inner and outer surface, that is T1 minus T4 divided by R thermal resistance. Now if we consider individual layers, then that will be equal to T1 minus T2 divided by R thermal resistance 1 when we consider this layer. So thickness is equal to L1 and its thermal resistance is R thermal 1. So as Q is constant throughout, so we can write Q is equal to T1 minus T4 divided by R thermal resistance equivalent, that is equal to T1 minus T2 by R thermal resistance 1. Similarly, we can write T2 minus T3 divided by R thermal resistance 2, and that is equal to T3 minus T4 divided by R. So if K1, K2, K3, L1, L2, L3 all are given, then finally we can find the rate of heat transfer through this composite wall, as they are in series. So we can directly add R thermal resistance 1, 2 and 3 to get R thermal resistance equivalent, and finally we will get Q, that is equal to total temperature gradient divided by total